lesson is on volume of prisms and cylinders. So volume is so much easier than surface area. Trust me, there are no like super complicated formulas. A lot of them are very straightforward. You're either dividing by a number, cubing a number, squaring, or dividing, things like that. It's not super complicated. So the volume is a measure of space that an object occupies, not what an object can hold. It's strictly just the amount of space it occupies. So what an object can hold in a liquid form or whatever else you want to put in it is called our capacity. And we're going to get to that in a couple lessons here. But for today, we're strictly dealing with volume and volume of prisms and cylinders more specifically. So the volume of this prism here is the area of the base times the height. So the area of my base, this here is a rectangular prism. So my area of my base is length times width. So my volume is now going to become the area of my base, which was length times width. And I'm just going to multiply it by my height. So now volume is going to be equal to 27 times 39 times 35. When I multiply those all out together, I get 36,855 centimeters cubed. Now, super important thing to remember here is that when we are dealing with volume, we are dealing in cubes, cubic units. And the reason they're cubed is I took 1, 2, 3 terms and multiplied them together. Surface area, I took 2 terms with a unit. Today's lesson, we're taking 3 terms with the same unit to get a cubic unit. All right. Next example is a cylindrical prism. So a cylinder. For a cylinder, my volume is going to be equal to pi r squared times h. Now, all of these formulas can be found in your notes package. It's like the second or third page in. They're all there: volume, surface area, slant height. All of those formulas you're ever going to need for this unit are there. There's also some conversions in there just in case you're in need of them. So we don't need to find anything here because we're given everything. So my radius is equal to 26. My height is equal to 26. That's kind of silly, but that's okay. We're going to go pi times 26 squared times 26. When I go pi times 26 squared and then times that by 26, I get 55,216.63 cubic centimeters. So what I did was in my calculator, I went 26 squared equals, times that by 3.14 or the pi button on my calculator, and then times it by 26. This here is what you should get for an answer. Example number 3. Now I have this weird composite shape, so I have to split it up into multiple different shapes. I'm going to take the easy way and we're going to split it right about here and here. So I have 2 rectangular prisms that I'm dealing with. So my one prism is going to look like this. Hold on here. It's not going to look like that. Give me 1 second here. All right. My one prism is going to be something like this. And it's going to be 12 by 18. And this piece here is 15. Now the back one is going to be something like this, where I have an X here, a Y here, and I need to know what those X and Y's are. So I know that the height is 12. So to find what the value of Y is, I'm going to take the 18, because the Y is this whole back side right here. This whole back side, sorry. So if I took this piece and this piece, added them together, I'm going to get what Y equals. So Y is going to equal 18 plus 10. So it's going to be 28. And X is actually going to be this whole piece minus the 15 from the other one. So that will give me what X is going to be. So if I went 25 minus 15, I'm going to get 10. So I now know what X and Y are, and that's all I need to know. So I'm going to take the volume, and it's going to be shape 1 plus shape 2. Got an E there we go. So the volume of this is length, width, height, plus length, width, height. Now the length, width, and height of my first one are 12 by 18 by 15. And my second one was 28 by 10 by 12. So now that I have that, I now can multiply these out, and I should get for shape 1, 3,240. For shape 2, 3,360. Add them all together, I get 6,600 feet cubed. Don't forget, it is feet cubed. Okay? Now we are going to take a look at finding missing values using volume. So we're going to write out the formula that we need for whatever object it is you're talking about. We're going to fill in all our known values, and we're going to solve for anything that we're missing. So this example says we have a rectangular prism that has a base of 5.2 by 7.8, and its volume is 142 meters cubed. What is the height of the prism? So I know I have a rectangular prism, which means I now have a volume of length times width times height. I know that my length is, say, 5.2, my width is 7.8, and my volume is 142. So I'm going to go take those numbers and I'm going to sub them in here. So I have 142 is equal to 5.2 times 7.8 times my height. First thing I'm going to do is I'm going to simplify this side of my equation. And by simplify it, I mean I'm going to take 5.2 and I'm going to multiply it by 7.8. And when I take those two numbers and multiply them together, I get 40.56 times h. And I still have 142 on this side. Now I want to get h by itself, so I have to divide out, do the opposite. What I'm doing, if I'm multiplying, I'm going to divide. If I'm adding, I'm going to subtract, vice versa. So here I am multiplying, so I'm going to get rid of this. And what I do to one side, I have to do to the other. So 142 divided by 40.56 is actually going to give me 3.50. So my height is equal to 3.5 meters is equal to h. So this one is in meters. Don't forget that it's in meters. You must use your units. However, they're not cubed because I'm not finding a volume. I am strictly finding a measurement or a side length in this case. And our last example is going to be dealing with capacity. So I lied to you earlier when I said we weren't dealing with it today. We are, we're just not dealing with it right away. So here we go. The capacity is the amount a three-dimensional object can hold. So if I was to pour water into it, or concrete, or balloons, whatever I want, it's going to carry this much liquid. So finding capacity when a liquid, so finding the volume of an object in centimeters. And then you're going to divide it by 1,000 and change your units to liters. So a can of chicken noodle soup has a height of 20, a diameter of 15. What is the volume of the cylinder? So first things first, we have to find the volume, and we want to find our volume in centimeters because we have this lovely conversion rate right here of using centimeters. So if we weren't in centimeters, we would want to be in centimeters, but we currently are in centimeters, so we're okay in that sense. So for right now, what we're going to do is we're going to find the volume. So I need to know for the volume of this what my radius is and what my height is. So my radius is going to be equal to half of my diameter. So I'm given a diameter of 15. I'm going to take that, divide it by 2, and I'm going to get a diameter of a radius of 7.5. I now have a height, and it's 20. So my volume is going to be equal to pi r squared times h. I like to write out my formula each time so I don't forget what it is. It helps me know what I'm looking for, helps me know what I need to find. So pi times 7.5 squared times 20. If I type this into my calculator, I get 176.71 times 20. Type that in, I get 3,534.29 centimeters cubed. Now this here is my volume. I also want to find my capacity. So my capacity now, what I'm going to do is I can cross multiply and divide, or I can just straight up divide. If you have centimeters cubed, you can just divide by 1,000. I'll show you the cross multiplication way just so you know how it works. So essentially we're taking 3,534.29 over x and setting it equal to 1,000 over 1 liter. So my centimeters are both in the top, my liters are both in the bottom. Your capacity is always measured in liters. You can change it after the fact, but it will always be measured in liters. So now I can cross multiply, where I'm going to take these two numbers, multiply them together, and then I'm going to take these two numbers and multiply them together. When I do that, I'm still going to be left with, my bad, 3,534.29 is equal to 1,000 x. Now that I have 1,000 x, I'm going to take and I'm going to divide both sides by 1,000 because I want to get x by itself. So now this is where that dividing by 1,000 comes in. If I divide both sides by 1,000, I'm left with 3.53429 liters. This here is my answer in capacity for liters. So you don't need to do the cross multiplication thing. If you're given centimeters cubed, you can just divide by 1,000. That is perfectly acceptable. If you're not given centimeters cubed, you're probably going to want to change it to centimeters before doing anything else because we only have a conversion for centimeters right now.